Well, hi everybody. It's time for us to grapple with a knotty little problem in the area of the continuous random distribution variable, and this is a kind of like a problem-solving problem. And the deal is that you have to try this after I reveal the problem to you before you have a look how I did it. Okay, that's the only way you're going to learn something from this and get something out of it. Okay, you ready? Fasten your seatbelts. So we're going to do continuous random variables and distributions, revision problem. Da-da-da-da. Okay, off we go. Whoa, look at this. Now, the time taken to complete a homework assignment, a very pertinent topic, has a probability density function of, right, we've got f of x equals kx, linear, but linear guys and gals, from x is 0 to 4, and that's another way, that one there is another way of saying minus k times x minus 8, which is the way I prefer to think of it, from x is 4 to 8, which that really means, I can spot that a mile off, that means that you've got minus kx, same deal as this one, same, just the negative gradient, and it's displaced, translated positively over in the x direction by how many units? 8 units. Very good. And this is 0 for everything else. You have to really watch that 0 bit, because if they ask you to draw the graph in the exam, you better make sure you show them the 0 bits, otherwise they get very narky and take marks off you. Right, okay, now we've got to find k. We've got to then find the expected value mu and the variance of the time taken to complete the assignment. What fun. Then we've got to find the probability that this beastly looking thing here, yuck, what's that? Well, we'll come to that later. And D, find the value of A such that the probability of X as being greater than A is 0.6, giving your answer correct in one decimal place. Well, fun, guys. Pause the video now and off you go, and come back when you're ready, okay? Hello there, you're back. Well, how did you go? I hope you went okay. I think C is going to be the sticking point, part C, but never mind, it'll all be revealed to you in the fullness of time. I'm drawing the graph for you now because I'm a picture person. I need a visual thing so that I can figure out what I'm doing. And that's it. Now, I've got to find k. Well, how did you do that? Well, guys, the secret is that the area under a probability density function, which this is, because it said it in the first line of the statement of the problem, is that the area under the PDF has to be 1. So I'm just going to work out the area of the triangle, guys, and set it equal to 1, and hopefully I can solve it for k today. Hooray! Area under the curve equals 1. Yes, it does. Base times height over 2 equals 1. Did you remember that formula? I hope so. That's a triangle. So the base, what's the base? Come on, 8. And the height is 4k over 2 equals 1. And easy as, yes, you can solve that. You can cancel out the 2, bottom and top. And you get k equals 1/16. Did you get that? Good on you. That's really good. Okay, so that's A, done. Now we've got to find the expected value mu and the variance. Now this does get a little bit hairy here, so this is probably better to do it as a calculated question, because it does get the algebra gets a bit intense. But you know, it's good to do the algebra anyway, to give you plenty of practice. That builds your confidence. You've got to be careful with what you're doing, and there's no better way than practicing things that are a little bit intense, you know. Okay, so here comes part B for you and me. I've redrawn the graph again for you, so we just get a bit of a visual stimulus. And did you notice how I drew these things nice and heavy and thick with the arrows there for the 0 bits? Because if they ask you to draw the graph, I'll just repeat that in the exam, and you don't do those bits, you're gone. Okay, so do that. Now the expected value, do you remember what that is? Do you remember? Okay, well, I think it is. Here, it's about to be revealed to you. Yes, it's that. And it's that, isn't it? X times f of x with respect to x. Okay, but unfortunately this f of x is a hybrid function. So it's got 2 bits to it, so we've got to do it in 2 bits. Yes, we do. So it's 1/16 of x times... Now, the 1/16 is the k, guys. I put that outside the integral sign because you just don't need to integrate constants. This is the x, this is the f of x with respect to x. That's the first bit. Here comes the second bit now, from 4 to 8, of that same, the second part of the hybrid function, which is this bit here. Yeah? Okay, now all we've got to do is just slog through the algebra and we'll get a very fine answer, I'm sure. Okay, that's a bit odd. Now, do you agree with that? See, I've just integrated this little thing over here. It's a third of x cubed, isn't it? Yeah, no problem. Good. Now, what have I done now? Ah, yes, I've just integrated this thing. Now, I called that 8x, which gets you to 4x squared. And I call this one here minus x squared, which gets me to minus the third of x cubed, doesn't it? From 4 to 8. Now, that's going to be pretty troublesome, but we'll just plot away. Step by step, inch by inch, anything's a cinch, but don't do it mile by mile because that makes you an algebra hero and you're likely to come unstuck. Okay? Good, let's go. Now that first one, good heavens, what did that happen? Oh yes, 4 cubed is 64 over 16 times 3. Very nice. Yeah, that's very easy. This one won't give up without a fight. This one's going to be more difficult because there's no nice convenient zeros as one of your terminals. So let's go for it. Now, what have I done there? That looks like the thing evaluated when x is 8. Let's see if I'm right. So it's a 16th times 4 times 8 squared. That's right. This one's a 16th times 1/3 of 8 times 8 squared, which is another way of saying 8 cubed. Okay, but I just split it up into that because I could see that 16 went into 64 4 times. So it's a bit of a more convenient way of writing it. Now we've got to do the whole same thing of that second square bracket with the 4, only minused, okay? Get it? Let's do it. So that's what you get with the 4 thing, okay? Now, oh goodness, I think I need to go over the page. It's going to be very nasty. Okay, yes, that's where I got to. Now, what I've done is I've started cancelling, okay? Okay, let's do some more. Yeah, okay, let's do some more. Ooh, very nice. Now, I can't really cancel that square bracket until I get rid of the bracket first. So let's just do a clean-up line. 4 over 3, first term. 16, second term. 32 over 3, third term. Now I'm going to get rid of the bracket now. Yes, I agree with that. Do I or don't I? What's that last one? Oh, 16th times 4... 4 cubed is 4 squared, which is 16. That bit there's the 4 squared times 4. That's 4 cubed, that bit over 3. Yes, everything's good. Okay, let's do some cancel-orama. Great. Now, where does that get us, guys? See, it does get a bit intense, doesn't it? Okay, that looks like... Oh, that's going to come out to be nice and easy, won't it? Alright, so it looks like it's 12, which is... let me see now. 16 minus 4 is 12. And this is going to be 4 plus 4 is 8 from 32 gets us minus 24 over 3. Yes, good. Now, 24 over 3 is 8. Goodness gracious me, and which gets me 4. Oh, who would have known? That's the expected value of that little function. That's very good, isn't it? So that's... Oh, no, we've got to do the variance now. Oh, that's going to be more revolting, because the variance is the integral of x squared times f of x with respect to x. Gurky. All right, come on. Fasten your seatbelts. Here we go. Oh, that's the... what I've showed you there is... This is very exciting. I've done this on the calculator for you. Now, up here... What I've done there is I've defined this on the calculator as a hybrid function. See that? Yes, that's from 0 to 4. This one here is the second one from 4 to 8. And you just define that, you store it to f1 of x. And then all you have to do, guys, look at this. It's as easy as you just do an integral from 0 to 8. And all of this splitting from 0 to 4 and from 4 to 8 is all taken care of in this integral. Isn't that a clever little calculator? So it does that and it just works it out well. It's just no trouble at all when it works it out like that, isn't it? It's beautiful. So how do you like that? So please remember that. The hybrid functions are great for doing integrals. You don't have to worry about it. Okay, yeah, and get 4. Yes, we do. Now, okay, so onward ever onward. We've got to trudge through some more beastly mud now. This is the variance of x, okay? So that's the formula. You know that formula, don't you? So we've got to work out the expected value of x, the expected value of x squared, because we've already worked out this one, and we're just going to, that was 4, so that'll be 16. But we've got to work out this beast now. So you ready? Chill pill at the ready? Here we go. Okay, now just don't be an algebra hero. Be careful, okay? Be very careful. So that's the deal. It's, yeah, x squared times f of x, which is, that's f of x in that half of it. And that bit there was, yeah, that was f of x in the other one, right? Yeah. Righto, let's go. Come on. Okay, now, you can see that this thing here is x... Oh, heavens, I forgot to push the stop button. Sorry, guys. That's x cubed, so that gets you a quarter of x to the 4th. Now, this one here is 8x squared, which gets you 8/3 of x cubed, and that one there is minus x cubed, which gets you a minus a quarter of x to the 4th. Oh, I can feel the chill pill is needed, a double dose, I think. Now, so where am I going with all this? Okay, so that's the first. Oh, that's the first term. That's this one. Evaluated gets me that. Now, the second one's going to be more troublesome. Okay. So we get 1/16 of 8 over 3 times 8 cubed minus 1/64 of x to the of 8 to the 4th. That's the first terminal evaluated. That's the 8 evaluated. Now I've got to do minus the whole thing with the 4. Okay. Yes, it's a beast, isn't it? It's an absolute beast. So that's, if you're not careful, you're going to come a cropper with this stuff. So be very jolly careful. So it looks like the first term evaluates to a 4. How simple, eh? Very simple. Okay, the second term, I'm doing a bit of simplifying there. That looks like I get... Oh, well, once I worked it out, it came to 256 over 3. The third one's 64. That's nice, isn't it? Okay, the next one was minus 32 over 3, and then I got plus 4. Well, I'm near the end, but it's nasty, isn't it? I mean, there's no two ways about it. Okay, now, whoa, gee. Okay, well, that comes to... Oh, look at that. How interesting. So then, I think that's going to come out to be reasonably simple. I need to put everything over 3. It looks like it's 56 over 3, which is 18 2/3. How incredible. Thank you, Mr. Box. So that's e of x squared. Okay, now we're just a moment away from victory with this. We want the variance, don't we? Okay, so it's that thing minus 4 squared, which was 16, which is going to get us 2 1/3. Doesn't it? I hope so. Otherwise, I am toast. Yes, 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 hurry up. Yes, there it is, 2 2/3. Oh, did I say 2 1/3? I don't know. 2 2/3. There you go. How marvellous. Now we've done it, guys. Now, here we go now. What have we got to do now? Oh, yes, the beastly bit. Okay, come on. Oh, there's the numerical way of doing it. Look at that. Isn't this marvellous? Look, x squared times f1 of x gets us exactly what we just got. And now I've worked it out here. There's the e of x squared minus e of x all squared, and I got 2 2/3. How sweet it is. Yes, yes, and yes. There you go. How marvellous. Now, we're going to do this beastly bit now. The probability... Oh, luck. Okay, now, never fear, my children. It's not as hard as it looks. Now, there's the graph redrawn with the value of k now put in there numerically. Now, what we've got to do is sort this horrible-looking abstract expression out. Now, I want you to think for a minute. What is mu? You know what mu is. Mu is 4, isn't it? Now, think about x minus mu. It's saying that the absolute value of x minus mu has got to be up to but not including 2 units. Now, if you're in doubt, think about some values, guys. Okay, here's mu. Now, what if x was 6? What would x minus mu be? Well, it would be 2. So that looks like that's one limit to our x minus mu. What about if x was 2? Well, 2 minus 4 would be minus 2, but once we modulus it, it gets us back to 2. So in a very real sense, we're saying that the modulus, or the absolute value of x minus mu, really just means the distance from x to mu. Just the distance from x to mu. And I often think of modulus just like that. Just like that. Another way of saying it would be x minus mu would be less than plus or minus 2. Okay? That's without the modulus sign, okay? It could be, yeah, plus or minus 2, or less than plus or minus 2. So that's another way of doing it, but I prefer to think of it as just a distance thing, really. It really helps when you do that. Okay, so is the mystery unmystified for you now? Yeah, so let's just do it pictorially for you. There's mu is 4. There, that's what x is allowed to go from 2 up to 6, but not including either. But with a continuous probability density function, it doesn't matter anyway, because the probability of right on the knocker of being 2 or 6 is 0 anyway. Okay, so all we've got to do, guys, is work out that. That's it. And when you do that, you'll be happy, just like me. Okay? Do you get that? I hope you do. Yeah, just the distance of x from mu has to be up to but not including 2 units. We need the shaded area shown. That's what we need. Now, in order to do that, I'm going to be a bit tricky, and I'm going to work out those two little left and right hand triangles and subtract that from 1, because I find that a bit easier than that funny looking shape, the blue shaded shape in the middle, straddling either side of the mean. Okay, let's go for it. Now, those triangles, there's 2 of them. They're now, by symmetry, they'll be 1/8 high, and there'll be 2 along the base, and it's base times height over 2, and there's 2 of them. So what are we getting? We're getting 1 minus 1/4, which is 3/4 is the blue shaded area. So the probability of this thing is 3/4. Da-da-da-da. Thank you, Mr. Box. How did you like that? I think it's rather good. So there's another one to tuck away in your little toolkit of tricks, and that is that the modulus of something is really describing the distance of one thing to another. For example, modulus of x. Now, you know what the graph of modulus of x looks like, don't you? Yes. Well, it's really describing the distance of any x value relative to the origin. It's really like the modulus of x minus 0, isn't it? Of course it is. So that's another one where you can think of it in that way. And whether x is positive or x is negative, the distance from 0 becomes the same beast, okay? It doesn't have a negative or a positive anymore. It's just the distance. Okay, now, where are we going with this now? Okay, we've got to find... Oh, this is the next bit. We've got to find the value of a such that the probability of x being greater than a is 0.6. Well, this is the anticlimax, guys. We've done the hard bit. Giving your answer correct to 1 decimal place. No problem. Here it comes. I'm going to draw a picture because I'm a picture man and I need a picture. There it is. There's my picture. Now I need the probability that green shaded area is 0.6, okay? So therefore I want the area of that thing on the left to be 0.4, and that's easier for me because I don't have to fiddle around with 2 different half hybrid functions, okay? So I'm going to do the bit on the left. So I just need the area of that left-hand shaded bit being 0.4, and I can easily work out the area of a triangle as follows. Okay? Now, it's 0.4, isn't it? Now, what's the area of a triangle? Base times height over 2. Yes. Well, the base is A. What about the height? Well, it's Ka, isn't it? And K is 1/16. Yes, that's it. So now, we can easily do the area of this triangle now. Oh, look. How beautiful. There it is. So it's basically A, which is the base, times A over 16, which is the height, and times a half, base times height over 2. And that equals 0.4, which is 2/5, yeah? Now, come on, we're going to work out A now. A is ours for the taking. What is it? Yeah, 64 over 5, therefore A will be 8 over root 5. Beautiful, and you don't have to simplify that. You don't have to rationalise the denominator, and if you do and you mess it up, you lose your marks. So just be a bit careful before you start prettying things up. So there it is. Thank you, Mr. Box. It's beautiful, isn't it? And we did it together. And you're a star. I hope you got something out of it. I hope you enjoyed it. And I hope you've got a new perspective on what the modulus really means. Okay, thanks again, and we'll see you next time. Bye.